Am I audible?
Yes, sir.
Okay, in the last class, we have started discussing about what are the different components present inside LPC2148. We have understood that LPC2148 presents the memory, SRAM, and the flash memory. It also provides three types of buses. We have studied called local bus, advanced high performance bus, and the VLSI peripheral bus. These three buses forms what is called as an AMBA architecture, advanced microcontroller bus architecture. And also we have studied that it provides a vector interrupt controller to be able to receive many number of interrupt requests and just select it one to be given to the ARM core. And then we have understood that there is a lot of requirement of different blocks is required to support different types of devices which are outside the microcontroller. So we have a general purpose IO to support the LCD, LED keyboard interfacing. We have an A to D converter to support the sensor interface, the timers to implement the timer and counting related jobs, and we have a PWM to support the speed control of the different types of motors. Then we also understood that there are four blocks are present inside this one, which supports what is called serial communication. So UART, which is maybe used to connect to a computer, the SPI may be used to connect to an SD card, I2C bus to connect to the sensors, USB 2.0 to connect to a through USB port to another host device. We also studied real-time clock, which keeps record of the date and time stamp. And we have a watchdog timer, which helps whenever the program hangs to come out of the hanging. So these are the different blocks we have studied. Now what we will do is, so in each class, we will take one block and understand how it works and how to program that block and how to use the pins provided for that block. So to start with, we will take what is called general purpose IO block. So as the name says, general purpose IO block is provided to interface to many of the general purpose devices like LCD, keyboard, and everything. Now we will see that how this can be done using these pins and this block. So these are the three buses. What I was talking about, it's called as a AMBA bus architecture. So these are the different clocks which has been used inside this one. We know that CC clock is always considered as a CPU clock. So there's one more clock called P clock is there, which is derived from a C clock. And both the C clock and the P clock are generated from the on-chip PLL modules based on the crystal connected to crystal 1 and crystal 2. So two PLL modules are there. So one PLL1 is used for USB related clock generation. PLL0 is used to generate the C clock. So if you connect the crystal and the crystal 1 and crystal 2, so the range of frequencies what you can generate using the PLL is 10 megahertz to 60 megahertz. By default, always the peripheral clock is 1/4 of the C clock. The C clock divided by 4 will be the P clock by default. If there is no PLLs are used, if it's disabled, then whatever the crystal frequency you connect, that will become the CPU clock. If you connect the 12 megahertz crystal, your CPU clock is also 12 megahertz. P clock becomes 3 megahertz, 12/4. If PLLs are enabled and properly configured, then if you connect that 12 megahertz crystal, your CPU clock becomes 60 megahertz, that is into 4, it's multiplied by the PLL, and the P clock will be divided by 4, that is it will become a 15 megahertz. Now we will start understanding about the different ports what is present inside this microcontroller. Now there is a one block which is present inside this one. That block is called general purpose IO. So this block provide all the signals necessary for interfacing general purpose devices. All the pins, whatever provided here, will be grouped into two ports. They're called the ports, means it's a window or a set of lines will be abbreviated by one name, and you can access that name or that port in the program as one set. So that is called as a port. So all the pins, whatever there here, which comes out of this block, are grouped into two ports. So they'll be called as a port 0 and the port 1. The port 0 is a one port, is a 32-bit size port. Both the port 0 and port 1 are 32-bit in size. When I say 32-bit, that means that there are 32 pins are associated with this port. So there are 32 pins are associated with particular the port 0. So what are the 32 pins? So you can call those pins as P0. Port 0 will be generally called as P0, P0.0 to P0.31. So in these 32 pins, what is supported by the port 0, some pins are not available for use, but they have discarded those pins. It's meant for something else. So what are the things which are not used? P0.24, 26, and 27. So these three pins are not available for usage. So, and there is a one restriction on P0.31. It is used only for output. So generally the port pins, whether port 0 or port 1, they are meant for both reading and writing. That means that each of the pins I use them for either reading purpose or for a writing purpose. So summarizing, port 0 pins are named as what? P0.0 to P0.31 in the program. Except these three pins, all other pins can be used. So totally how many pins are available now? Totally 29 pins are available in the port 0. Similarly, there's a port 1 is available. This port 1 is a 32-bit port. In this, not all the 32 pins are available here. Only 16 pins are available. What are those pins? P1.6 to P1.31. Actually, when I say port 1, it refers to what? P1.0 to P1.31. But the manufacturers have provided the pins only on the 16 bits. So that means that those bits or those pins of the port 1 will be called by the name as P1.16 to P1.31. That is, upper 16 bits of the port 1, they are available as a pins outside the chip. The lower one is not available. So totally effectively, how many we have here? 16 here available here. 16 plus 29. So 16 plus 29. Totally 45 GPIO pins are available in LPC2148. So if you want to develop a project, always keep in mind, maximum number of pins it is available, it supports is 45 pins are available. They are all called as GPIO pins. They can be used for reading or writing. So port 0 provides 29, port 1 provides 16. So totally 45 pins are there. They have grouped these pins as two parts, port 0 and port 1. So in the program, I can just access port 0, all pins simultaneously. I can write something into port 0 equals something I can write. Or I can write port 1 equals something. So the grouping is done such that all those setup pins can be accessed in the program as one set for reading or writing. Now, so once I have these pins are located on the chip. Totally, I said the chip is a 64-bit chip. So in this 64-bit, you can look at these, the pins are distributed in the different parts. For example, let's say, look at here. This is P0.0. So similarly, this is P0.1, you can see here. P0.2, you can see here. P0.3, so P0.4, like that. The pins of the port 0.0 to P0.31 and port 1 chips, you can look at that, port 1, P1.23, like that. P1.16 to P1.31 are distributed on the chip. So when you want to build a project, for example, I want to interface an LED. So LED requires one pin to connect to the LED. So then I have to choose one among the 45 pins. Which pin I have to choose? Any one I can choose among the 45. Let's say I'm taking P0.0. Then what should I do? So you should go to this point, that is pin number 19, then take one wire and you have to connect this wire to an LED and you should be able to do it. That means that we can able to interface the devices by appropriately choosing what is a pin required and then we are going to do it. So generally we don't take the chip and make the connections. What we do, we build a circuit actually. Then we will get it manufactured and then we will do it. Most of the times what will happen is we will have some boards designed using this chip. In that board, we would have connected to the different components. We will ask you, So this is the board already available. These are the components already connected. Please do write the programs on that one. That is how we conduct a lab experiments. So in the lab. So, but when you want to do a project work, what we do, you have the freedom to choose whatever the pins you require, and whichever you want, you can connect to the component and make the whole circuit connection ready, and then you go for manufacturing of the board or your own product. So now we have started identifying how to connect the general purpose devices using the chip. So these are the 2 pins. So now we have got an idea that these are the pins available for interfacing. Now we will understand how to do the programming, how to access them, what are the requirements. Now, so if you look at this pin, let's take one pin. Let's say P0.5 is a pin we are going to take it. Let's say P0.5. Look at this pin. Look at this pin for a moment. I will just, you can see that P0.5 slash MIS00 slash MAT 0.1 slash AD 0.7 is there. That means that there is a 4 meanings are given. Am I audible?
Yes, sir.
Yeah.
Yes, sir.
There are 4 meanings are given to this pin. Why do I have to give the 4 meanings, multiple meanings to a single pin? Look at, I said the total number of pins for this chip is what? 64 pins. How many pins are gone for the GPIO? 45 pins. How many for the crystal? 2. How many for the VSS and VDD? Because multiple VSS and VDD is there. So that means that almost 50-55 pins have gone only for GPIO, crystal and power supply. If you look at the circuit, so you can see that a lot of blocks are, see, SPI requires so many pins, UART requires so many pins, RTC requires some pins, ADC requires so many pins. That means that 64 pins is not sufficient to accommodate all the pins provided from these blocks. Look at that. There are more than about 100 or 120 pins which are coming out of the different blocks, including ADC, GPIO, and all these blocks put together. But the chip, if you look at the chip provides only 64. This is the problem with all the microcontrollers. That is, they want to keep the size of the microcontroller less. When the size of the microcontroller less, what will happen? The power consumption will be less and the cost of the chip will be less. But whereas if you look at the inside the chip, the facilities, what is provided inside, so many blocks are there. Each blocks want to talk to the external world through the set of pins. The number of requirements, that is, the facilities provided inside the chip requires so many pins. But because of the cost and the power dissipation, we want to reduce the number of pins. So that is why almost all the microcontrollers follow this one with what is called as duplexing. So you can call it a multiplexing. So that means that single pin will have multiple meanings will be there. So we do what is called pin multiplexing. So if I take this pin, for example, I indicated here. So I can use the same pin for 4 applications. That is what they are given //4 meanings they are given it. So if I say 4 meanings are there for one pin, you may ask the question, sir, can we use all the meanings at the same time? It is not possible. You can able to use only one meaning out of the 4. That means that, so if I choose this one, for example, if I using, for example, one pin for a general purpose, same pin carries the meaning of, let's say, from another block called SPI block. So now you should take a decision. If the one pin which is being shared for this block and this block, which one you are going to use, you should take a decision. If I'm using for this purpose, I cannot use this block for that functionality. So if there are 4 meanings are provided for a pin, so each of the meanings will be supported by what? 4 different blocks, maybe one from here, another from, so it can be, let's say, here. That means that if I'm talking about one pin, these pins are connected to 4 different blocks inside. You can use any one meaning of the pin. So if let's say I'm using the meaning of a pin, that means that GPIO, I want to use this pin as GPIO pin. Then what will happen? All these are disconnected. All these are what? Disconnected. That means that you can only use for this purpose. You cannot use this pin for this meaning. So this is what is a limitation of any microcontroller. If there are 4 meanings are there, any one meaning of it. If you can use A to T converter, I cannot use the pin for general purpose IO. So when you design a project, you should see that how many requirements of GPIO is there, how many ADCs is there. You should able to what is called negotiate. You should able to negotiate what is required, what is it. You have to do what is called some you try and you have to allot and then remove it, allot, remote. You have to do some experimentation, what is required for you. Then you will able to come down to a final solution. Oh, these are the pins I can use for this logic and everything. So this requires some experimentation required whenever you design a project. Because why? Even though 64 pins are there, they may not able to support all the functionalities what is provided inside. For example, I am not using an I2C. In such case, what you can do is I2C pins, you can use them as a GPIO pins. For example, I'm not using SD card in the project. The pins allocated for the SD card interface, use them for the GPIO pin. Like that, you should be able to negotiate. So if I don't require that many GPIO pins. I require only 3-4 GPIO pins is sufficient. Then you can use the pins for what? For SD card interface, for I2C, like that. Like that, you have to negotiate for what logics you require, what you have to do. So you have to write down the paper, you have to experiment, you have to see that what is required. So after doing certain negotiations, some writing on the paper and everything, you can come to a conclusion, oh, these are the logics I'll be using. Not all the logics what is present inside the microcontroller are always used. Only few logics are used, few logics are not used. Depends upon your project requirement. This is the limitation of every microcontroller. This you have to keep it in mind. Even though all blocks are there, that does not mean that all blocks, every feature you can use it in a product. So that is why this is called pin multiplexing is done. So summarizing, the pin multiplexing is a concept to accommodate more functionalities in the less number of pins. The functionalities inside the chip is more, but the pins are less. So to accommodate less number of pins to support more functionalities, multiplexing is done. So in case of LPC2148, every pin is nothing but 4 alternate functions available. Every pin can able to support 4 alternate functions. So what are those functions? I've selected an example, P0.5 I selected. So if you look at that, P0.5, whatever I indicate in the arrow, so I've just selected that indication. I'm just explaining with reference to that. Now, so if you look at here, here, am I audible?
Yes, sir.
Okay. Is PPT visible? Yeah. Okay. Okay. I have just selected this P0.5. I'll explain with reference to that how multiplexing is done and how in the program we can control that which is a functionality you require it. Now, so if you look at the GPIO, I selected pin 0.5. This is what is there inside LPC2148. Inside LPC2148, for every pin, there is a logic called pin select multiplexer is there. Pin selection multiplexer. That is, for every pin, there is a one pin select multiplexer is there. This pin select multiplexer receives the 4 inputs from the different blocks present inside the microcontroller. For example, for pin P0.5, pin select multiplexer receives the input from GPIO block, from SPI, that is a SD card interface related block. The match, that is match registers are there. If you look at here, the match registers are there in the capture compare. So here, okay, they are part of this register. Mat input is there. So that means that, so it's a timer counter block. So timer counter block, and this is ADC block. That means that the P0.5 related pin select multiplexer receives the signals, receives the input from GPIO block, SD card interface block, the timer block, and the ADC block. So one data from each of these blocks have come as an input to the pin select multiplexer. Now, it is the responsibility of a programmer before starting the project to identify which part of this 4 is required for my project work. Am I using P0.5 as a GPIO? If you're using as a GPIO, then what will happen? So you should use this pin P0.5. The P0.5 is used. Let's say I don't want P0.5 to be supported for the GPIO. I want to use them as an ADC input. Then what you do? You should disconnect this one and you should use AD. So same P0.5 now act as what? AD 0.7. Even though name is P0.5, I just indicated here. Now instead of P0.5, what will happen? The pin will be called as what? AD 0.7. So I can call the same pin P0.5 as P0.5 or a pin related to this one, pin related to this one, or I can call it as 80.7. So 4 functionalities. Among the 4, I have to select one functionality. So this is a multiplexer. How do you select 4 or 4? How do you select one from the 4? We require 2 bits. So 2 bits. If I write 000, that means that what functionality? I'll be selecting the first functionality. If I write 01 here, I'll be selecting the second functionality. If I write 10, I'll be selecting what functionality? Third functionality. If I write 11, then I'll be selecting the fourth functionality. That means that I require 2 bits to configure every pin of the microcontroller. Now, how do I configure? When do I configure it? Is it possible to configure before I start writing a program? Do I do in the software? Do I do in the hardware? You look at this. So if before start using this chip for a product development, you identify what pins are required, you make an hardware connections, everything is ready. But you have to inform into this chip by writing a proper instructions that mean that this pin has to be used like this pin has to be used like this. For that, what they do is they provide. How do I write that 2 bits? Say for example, I'm interested to make this particular bit as, let's say, 80.7. So then what should I write? I should write 11 there. I should write 11. So 11 I should write where? Into the pin select multiplexer. Somewhere here I supposed to write it. Where is the pin select multiplexer? It is present inside the LPC2148. That means that inside the LPC2148, there should be a place where I can write these 2 bits of information. This is, I'm talking about what? 1 bit, P0.5. Like that, you should able to configure what? P0.0, P0.1, P0.2. That is all the port bits of the port 0. That is how many bits are there? 29 bits, whatever there. You have to configure for what purpose is required, because each bit has an alternate functions there. Each pin corresponding to port 0 and port 1 have got alternate functions there. So that means that 2 bits are required for 1 pin. So for example, how many pins we have? 30, let's say 45 pins are there. 45 into 2 bits required. How many? 90 bits are required to configure the different port pins to work as per our programmer requirement. So 90 means, so we know that all the register inside the LPC2148 are 32 bits register. So if I say divide by 2, it is not possible. So that means that I have only 32 bits. Every register can be 32 bits. 32 bit registers are there. So I require 90 bits are required. So one 32 bit register not possible. So 2 is not sufficient. 3 is sufficient. It may be more, but 3 is sufficient. So totally how many bits, how many registers are there? So totally 3 registers I require now of 32 bit size to configure the functionality or multiplexing value or the meaning of every pin. So these 3 registers, where should they be present? They should be present inside the microcontroller. Who can write that one? A programmer can write that one. How can the programmer can write in a C language or an assembly language? If there is an address for that register is there. Yes or no? If there is a name for the register is there. For example, in the C language, if the name is there, I can access that register. So if it is in an assembly language, I should know that what is the name or address of that register. Then I can able to access that one. Now, such registers are present inside the microcontroller. There are so many such registers are inside that one. They are called as programmable registers. These are the registers you should able to understand whenever you want to use the microcontroller. Now let's see that what are the 3 registers present inside which are used to select the functionality of each of the pins. Now, so these are the 3 registers are there. They are called as pin selection register. The name of the register is called as a pin selection register. How many registers are there? Pin selection 0, pin selection 1, and pin selection 2. These are the names of the registers available. So pin selection 0. So why 3 registers are required? I said every register has got only 32 bits. I require 2 bits for every pin. Now let's start with the port 0. Now port 0 has got one for P0.0 to P0.31. So 16 plus 16 I can divide them. So P0.2, P0.15 is half of the port 0, because every pin requires 2 bits. That is why we take one pin selection 0 register. So pin selection 0 register now can be used to define the functionality of every pin P0.0 to P0.15. So why one register is required? Because every bit requires what? 2 bits. So 2 into 16, 32 bits. So now I have finished one. That is P0.20 to P0.15 in my program or in my project. If I am using means I have to configure in the beginning of my project means which register I should always look. Pin selection 0 register. Similarly, pin next register, pin selection 1 register used to configure port 0 pins 16 to 31, the next 16 bits of the port 0. So they are used, again 2 bits for each of the pin, 16 pins are there, 16 into 2, 32. The pin selection 1 is used. So now we have finished port 0. Now what is left? Port 2 is left. In port 2, we know that there is only 16 pins are there. What are the pins? P1.16 to P1.31. There are 16 pins are there. 16 into 2, 32. That means that those pins can be configured using a pin selection 2 register. So now these are the registers which are available for the programmer to configure these pins. So we should remember, if I'm using the P0.5 in the project, you should immediately find out, look at this table, you should look at, oh, P0.5 falls into this category, I should use pin selection 0. Let's say I'm using P1.25 in the project, so you should look at P1.25 falls into which category? Yeah, it falls into this category. So I'll be using pin selection 2 register. If I'm using P0.28, you should look at that, which category it should fall, or it should fall into this category. So I'm using pin selection 1 register. So you should be able to remember that given the port pin, you should know which pin selection register is used, so that you can able to, in the program, you can configure whether you require which of the 4 functions you require for that particular pin. So let's take an example and do it now. So this we have given for 1 register, I given pin selection register. So I said pin selection register, I have 32 bits are there. First 2 bits, 0 and bit 1 are used to configure what? Port 0.0. Now what are the 4 alternate functions possible? You can use this pin, P0.0 pin, as GPIO port 0.0 pin, or you can use as what? TXD pin of a UART logic, or you can use them as a PWM1 block. So, or you can, this is reserved, this is not used. So on reset, that means that if you don't program anything, always it will be configured for the first alternate function. So what is the first alternate function? That is 0, 0. That means that, so generally, if you don't configure the pin selection register, that means that you don't write into the pin selection register, on booting, these register becomes 0, 0, 0. Since it's 0, 0, 0, always the first function of the pin is being selected. If at all, if I want to select the second alternate function, or if I want to select the third alternate function or the fourth alternate function, in the programming, I supposed to write what? The proper value into these 2 bits. So what all I can write? Either I can write 0, 1, 2, or 3. So 4 options I can write into these particular bits. So the next 2 bits are given for P0.1. The next 2 bits are given P0.2. Like that, P0.15 is given to this bits is available. Now, for example, I want to write into the P0.6. You should identify what are the bits in the pin selection register you want to write it. How do you identify 12 and 13? You can multiply 6 into 2 because 2 bits are required for every pin. Multiply 6 into 2, 12 you get. So 12 and 13. I want to configure P0.10. So what should I write it? 10 into 2, so 20 and 21. Like this, you can able to configure the pins, and for whatever the purpose, you can able to use that purpose. Now, so I'm audible. Hello.
Yes, sir.
Yeah.
Yes,
so
sir.
Now, okay, we will go to a programming. We will understand and come back here. One moment. Okay. So now look at the pin selection 1. So in the pin selection 1, so you should able to very clear here. So in the the port 0.0 to 15 is in a sequence starting from 0 to 15. The corresponding bits are used here. Whereas when I go to the pin selection 1 register, pin selection 1 register is used to configure the pins 16 to here is not completely provided. It's you have to 16 to 31 is configured here. But how do I identify which are the bits used? This is where you have to little concept you have to understand here. So we will see that. Now, for example, say now pin selection 1 register is there. I know that pin selection register, I can configure what bits? I can configure, so P0.16, I can configure starting from that. I can configure up to P0.31, I can able to configure. So these are the pins I can able to configure. So don't look at this figure. Don't look at this figure only now. So totally 16 pins are there. These 16 pins can be configured by 2 bits for each pin using the pin selection 1 register. Now, let's start with the first one. So what is the first pin in the pin selection 1 register? P0.16. I have written P0.16 now. Now 2 bits are required. What are the 2 bits required? the first two bits are required, 0, bit 0 and the bit 1. So using that, you can able to configure the P0.16. Now let's go to the second pin, P0.17. 17 means I require 2 bits. So 0, 1 is already used for 16. So bit number 2 and 3 are used for 17. So that means that, so if I write, this is a register of pin selection register. Let's say this is a, so pin selection register 1, let's say pin selection register 1. So the first 2 bits, so it is being used, this first 2 bits, whatever there, it is used to configure this bit. So the next 2 bits, I am using to configure the second one. I configure like this. So like this I am continuing. So the question is, the pin numbers are not starting from 0. The pin numbers are starting from 16. This is where the confusion comes. Since it's coming from the 16, starting from 16 to 31, I found to find out which are the bits in the pin selection register, which is starting from bit 0 to bit 31. So which are the bits in this register are used to configure each of the pin. Since it is starting from 16, how do you calculate? So you have to do 16 minus 16 because you're starting from 16. So for example, what are the bits correspond to 0.16? 16 minus 16, 0. So 0 multiplied by 2 because 2 bits are required for every pin. So which are the bits required? 0 and 1. Similarly, what are the bits required in the pin selection register for the P0.17? So you minus 17 minus 16 because 16 you're starting from 16. So you get 1. 1 into because 2 bits are required for every pin, 2. So 2. So what are the bits here? 2 and 3. Like that, it is been explained. For example, I want to configure, let's say P0. I want to configure, let's say P0.28. I want to configure. So you want to configure the P0.28 means you should know which are the bits are required in this register pin selection 1. What should I do? 28 minus 16 I have to take it. How much? It will become 12. 28 minus 16 becomes what? 12. So 12 because 2 bits are required for every pin. 12 into 2, 24. So now in this register, I'll go to the bit number called 24 and 26. There I will write what is the required value. Every bit, every 2 bits I can write what? Either 0, 0, 0, 1, 1, 0 or 1, 1. I can write into that one. So this is how you have to identify what bits are in the pin selection 1 register are used to configure which pin. So this is there's one difference between here. Here why? It was directly starting from 0 to 15. You just multiply the number into 2, you would have got the bits. Here what? It's starting from 16. That's why what you have to do? 16 minus 16. So whatever the pin number, that minus 16 into 2 you have to do it. So this we have understood pin selection 1. Now we'll go to the pin selection 2. Pin selection 2 is a register which is used to configure the functionality of every pin of the port 2. Where does the port 2 starts? It starts from P1.16. P1.16 to P1.31. 16 pins are there in the port 1. Yes or no? Again, since it is starting from 16, what you have to do it? Whichever the port you want to configure, to identify which bits in the pin selection register, subtract the number minus 16, that is the starting where you are starting, into 2 because 2 bits are required for every pin. So then you will, let's say for example 17. So 17 minus 16 is 1 into 2, that is 2. So what are the bit numbers? 2 and 3. If I want to configure the P1.20, so which are the bits in the pin selection 2 register? 20 minus 16, that is 4 into 2, 8. So pin number 8 and 9, bit 8 and 9. So now I have understood in the last 5-6 minutes, that is every pin of the microcontroller has got 4 alternate functions. The names of the pins are called from P0 to P0.31 and the P1.15 to 1.16 to P1.31. These are the names of all the pins are called. So that is there all the pins are grouped into what is called as port 0 and the port 1. That is how the names are called. Now every pin has got 4 alternate functions are there. So using the 2 bits, programmable bits inside the microcontroller, I can configure which function I can assign for a particular pins. So since there are totally 45 pins are available, 45 GPIO pins are available, to configure them, I require 45 into 2, 90 bits are required. 90 bits I can provide using a 332-bit registers. So these registers are called as pin selection registers. There are 3 pin selection registers so that they'll be called by the names pin selection 0, pin selection 1 and pin selection 2. And every pin selection register has been defined by the manufacturer. This register is used to configure these particular pins. So pin selection 0 is used to configure the pins P0.0 to P0.15. Pin selection 1 register is used to configure the pins P0.16 to P0.31. Pin selection 2 register is used to configure the pins P1.16 to P1.31. So once I know that what register is used for what pins, then next question is what bits of the register are used for that pin. So for the pin selection 0, it's very direct. So whichever the pin you want to configure, that multiply into 2. So whatever the number you get, that and the next bit are used to configure that particular pin. Since both in pin selection 1 and pin selection 2, the pin numbers are starting from 16 onwards. So whichever the pin you want to control, that minus 16 you do it, into 2 you do it, then whatever the number you get, that and the next bit are used in that pin selection register to configure that particular the pin. So now, so once we have understood that, so we can always configure the pins by writing the programs. So we will do that before we start writing the programs. We will do that. We will finish another concept and then we will do it. Now, so once, if I am able to use the pins for whatever the logic I require it. So if I'm, let's say I'm using a general purpose IO pin, general purpose as a GPIO pins. GPIO means first selection. So after identifying what is the logic I require for every pin, then let's say I'm going to use that pin for a GPIO purpose. So let's say now we will understand how I can able to configure the pins for a GPIO block and how I can use them in the program. Now, before I start using the pins for GPIO block, what is my requirement? I have to configure these pins for GPIO purpose. As I said already, the first function, there are 4 alternate functions are there. First function of any pin is always GPIO. So even if you don't write into the pin selection register, by default, it will be what? GPIO, first function only. Now I have identified, I have configured every pin for the GPIO. Using the pin selection register, by default values, I would have done it. Now I have to start use these pins to connect the LEDs and the keys and the switches. Then what should I do it? Then I should understand the 3 logics. What are the 3 things I supposed to understand? First of all, since every pin of the GPIO block are available for reading or writing, I should able to inform in the program, in the beginning of the program, am I interested to use that particular pin as an input output? Even in Arduino, we did that in the setup function. So now we configured the input or output the function. Similarly, at the low level also, you're supposed to do the same thing only. In Arduino, all the functions, whatever you use, yes or no, they set the input and make the particular digital output, digital write, whatever you're using, no? That is, inside that somebody has written a code which controls the microcontroller functional. But here what will happen? There is no function called digital write, digital read, nothing is available. You have to write what is present inside that function yourself. That is how it is different, writing directly to the microcontroller and using the boards. So there, the functions were available, have been provided by the Arduino environment for you to write into the microcontroller. So those libraries are developed by the board manufacturer. Here, no board is there, only the controller is there. That means that what is the code present inside the built-in function provided by the board manufacturer, you have to write yourself now. Now we are learning how to write a 1 and 0s on the digital output pins now. So what is the first step I said? You have to configure the direction of the bits. Now, so let's learn how to configure the direction of the bits before we start using the GPIO pins. What is the register provided? IO direction is a register provided to configure the direction of the pins. Now, how many ports we have? We have 2 ports. One is called port 0, other is called as a port 1. So naturally, we require 2 registers are required. So one is IO direction 0 register, which is used to configure the port pins of the port 0. IO direction 1 is a register which is used to configure the direction of the port 1 pin. So these are the 2 registers which are present where inside the GPIO block of the microcontroller, a programmer can refer this name or address and he can write into that portion. So now we understood the direction. Now we'll go to the second aspect. So what is the second aspect of the programming the GPIO pins? Now, there are 2 separate functions or separate addresses, or separate registers are present inside the microcontroller to make a particular bit on or off. For example, let's say P0.0. P0.0 pin of the microcontroller, I can make it 1 or I can make it 0. To make it 1, there is a separate register is available. You have to use that register only and write into that register to make the P0.0 1. There's another register is there. So that register is meant for what? To making a pin 0. So whenever you want to make a pin 0, you have to use that register only. So what are those registers for the two ports? IO set is a register which is used for, so port 0, set 0. IO set 1 is used for what? Setting 1 on the port bits of the port 1. Now, what do I write into this register? Since this is a 32-bit register, see, direction is also 32-bit register, set is also 32-bit register. Why 32-bit register required? Because port 0 is 32 bits are there. Every bit of the register will control what? One pin of that particular port. For example, IO set is a 32-bit register. So set 0 is a 32-bit register. So each bit corresponds to what? One port 0 pin. For example, the first bit of the IO set 0 register controls the P0.0 pin. The second bit controls what? P0.1, like that. So the corresponding bits of this register controls the corresponding pins of that particular port. Now, what do I write to make a pin set? So they are indicated, we have to write 1. So writing 1 into a particular bit of the register makes the corresponding pin of the port becomes 1. Writing 0 have no effect. There's no meaning in that. You only writing 1 has got a meaning. Similarly, whenever you want to make a particular pin 0, then what I should write? I should write into the corresponding register called IO clear register. A particular bit is equal to 1. Then that bit becomes clear. So this is how we can able to use the set and clear register to configure a particular pin as what? Not configure, to write to that particular pin as what? 1 or 0. So this is the second aspect of a GPIO program. What is the third aspect? So third is called as IO pin register. For example, now I have told in the second case, how do we write 1 or 0 in a particular pin? That means that I'm sending the data out. For example, we also know that in IO direction register, we can configure the pin as what? Input or output also. Whenever you configure the pin as an input, that means that you're using a particular pin for reading the data into a microcontroller, then I'll use IO pin register. So IO pin register, whenever we read this register, we get the value what is present on the pins. For example, if I read IO pin 0 in the program, so I say variable called variable x is equal to IO pin 0, then what will happen? All the data present in the port 0 register will become to a variable called x. So reading IO pin 0 register, what do I get? The data present on the pin 0. This is how we read that. So two registers are provided, pin 0 and pin 1. Summarizing, GPIO programming or using the pins provided by the GPIO block has the three methods of accessing the GPIO registers or GPIO pins. First thing before using is always you have to do what? Configure the direction of the pins using the IO direction 0 and IO direction 1 registers for port 0 and port 1. Then two set of registers are provided called a set and clear register, which are used to make a pin as 1 or 0 through by writing a proper value into the set and clear register. Writing a 1 into a particular bits becomes a 1 on the corresponding pins. Then IO pin register is used to read the data present in the pins. So these are the set of registers. So the totally 6 registers are there. Yes, no, direction 0, direction 1, 2, here 2, here 2. There's 6, 7, 8. 8 registers are used. These 8 registers are used by the programmer in his program to access the ports. So what we do, we will learn about this programming probably in the next class. How do we do it? How do we write the program? So if any doubts is there, you can ask me the doubts.
Sir, for any particular pin, if both set and clear, both are set to 1, which will be defaulted, sir?
Can you tell me again?
We have a separate registers for setting and resetting the pin.
Okay,
clearing
correct.
the pin.
Yeah.
So if both are set to 1 for a particular pin, which will be taken?
Whichever the last one you execute.